Hello everyone. In this video, we'll be learning about the break statement. Let's do a quick review of the normal control flow execution of a while loop. As long as while loop condition keeps evaluating to true, we are going to run the lines of code within the while loop body. Right after we are done with execution for the last line of code within the loop body, we are going to go back to the beginning of the while loop and re-evaluate the condition. Immediately after the condition evaluates to false, we are going to terminate the while loop execution and we'll be proceeding with executing the lines of code that come after the while loop body. Let's learn about the break statement now. Break statement enables us to disrupt the normal control flow execution of a while loop. When you're executing the while loop body, if you encounter a break statement, you're going to immediately terminate the while loop body execution and you'll be executing the lines of code that come after the while loop body. Break statement is typically associated with a conditional. We'll be breaking out of a while loop subject to a specific condition. Break is very similar to return from inside a function, but please make sure to understand the differences between the both. Whenever you want to return some kind of an output from inside a function, you're going to have to use the return statement to return a specific value. Let's consider an example where we have a while loop which is defined outside any of the functions. Let's say that you want to disrupt the normal execution of that particular while loop, then you will have to use a break statement for that case. Let's consider the alternate scenario where we have a while loop within a function definition. Then you could possibly use a return statement inside the while loop body to both break out of that while loop and return a value from that function. Please understand that whenever you execute a function call, exactly one return statement will get executed. On the other hand, it could be possible that you can execute multiple break statements within a single function call. Let's consider a function definition which has two separate while loops, both of which contain their own break statements. When you break out of the first while loop, you're going to proceed with execution of the next while loop. Next time when you break out, that's going to take you out of the second while loop. Observe that the example scenario that I just went through led you to executing two different break statements within a single function call. So pretty much return is the only statement that you'll be executing exactly once within your function call. Let's talk about the usage for break. The most common use case for break is when you're searching for a specific value among many values. As soon as you've found what you're searching for, you can terminate your while loop and you'll be able to proceed with whatever you have found as part of the search. Let's go through demo problem for break. We are going to pick up on part 2 of prime search program. In part 2, we are going to write a function which takes two inputs. The first is going to be start of a range and the second is going to be end of a range. Then the function is going to produce a boolean return value of true or false depending on whether that particular range contains a prime number or not. Let's consider example ranges. If I say start is 14 and end is 16, the function is supposed to return false. That's because 14, 15 and 16 are all not prime numbers. If the start is 10 and the end is 12, then the function is supposed to return true. That's because 11 is a prime number. I'm going to switch over to Jupyter Notebook. Please pause the lecture video here and launch Jupyter Notebook. Make sure that you have a copy of the s underscore prime function which we wrote as part of the previous lecture. Let me do a quick walkthrough of the s underscore prime function. Recall that in order to determine whether a given number is prime or not, we need to try out all the devices from 2 up to num minus 1. to ensure that all of those devices provide a non-zero remainder. If that is the case, then number is prime. Even if you find one of the devices to give you a zero remainder, then that particular number is not prime. So we defined divisor as the loop condition variable. Then we are running divisor through the values of 2 up until num minus 1 by saying divisor less than num as the condition. Then we are checking the remainder that we get when we divide num by divisor. We'll be using modulo operator for that. If the remainder is 0, then divisor is able to cleanly divide num here. So we are going to return false in that case, as num is not a prime number. Then we have the increment line for updating the loop condition variable of divisor. When can we return true? Only when all of the iterations of the while loop here are done and we find that all of the devices provide a non-zero remainder, then num is a prime number. So we are going to have the return true statement outside of our while loop body. You can observe that by matching return with the level of indentation of this while keyword here. In cell number 2, we have sample arguments for the s underscore prime function call. 7 is a prime number, so you're getting true. 2 is a prime number, so you're getting true. 23 is also a prime number, so we get true. 16 and 24 are not prime numbers, so we get false. Here is a very large prime number, which is 1,000,003. Looks like we are getting true for that. Let's get started by defining the has underscore prime function. This particular function is going to have two configured arguments, which are going to be start and end. What we want to do now is to run our loop from start through end, including the start and the end values. So let me initialize the loop condition variable as num. I'm going to initialize the value as the start because we are going to start checking from start as the beginning of our range. My while loop condition here should be while num is less than or equal to end. We need to make sure to include end because as per the program specification, the end is included. You can say that with the example ranges provided here. When we say 14 to 16, we have an explanation saying 14, 15 and 16 are all not prime. So that implies that we need to run the loop from start up until end. It is always a good practice to use print function call first to determine whether your loop is getting executed correctly. So I'm simply going to print each of those numbers and let me run the function definition, and let's call the function by passing 14 and 16 as arguments here. Looks like I accidentally wrote an infinite loop. Let me show you one more time how to deal with this. You need to do kernel interrupt, and let me first fix this problem. I'm going to increment num value by 1. Then I'm going to have to say kernel restart and run all. That will fix the problem for you. This is precisely why I'm recommending all of you to use print function call to first do a sanity check on your loop. So now that we have the correct output for the current version of the program, let's proceed to using the s underscore prime function inside the has underscore prime function call. I'm just going to call s underscore prime function by passing num as argument here. You could possibly capture the return value into a variable, or you could just directly use the return value and subject it to a condition. So you can simply say if s underscore prime function call. What that implies is that this if condition is going to check the return value of this function call. Since the return value of the function call is a Boolean value, if the Boolean value is true, then your if condition will evaluate to true. What we want to do now is that we want to say that we have found a prime number, correct? whenever you're searching for something, you need to initialize your search target variable outside of your while loop. In this particular case, we just want to store a boolean value of true or false depending on whether we found a prime number or not, correct? So I'm going to define a variable called found underscore prime, and I'm going to initialize that variable with a value of false outside the while loop. Inside the while loop, as part of my conditional here, I have found a prime number. So I'm going to update found underscore prime variable to a value of true. So let's go ahead and return found underscore prime from inside the has underscore prime function. So I'm going to just type in return space found underscore prime. Let me re-execute this function call, and I'm going to execute the corresponding function call as well. Sorry, I meant re-execute the function definition and execute the function call below it. Looks like we are getting false, which is the expected output. What if we try the other range from the slide, which gave the start as 10 and end as 12? Looks like we are getting true in that particular case. Let's try large numbers for our range here. I'm going to try million as my start. So that's going to have 6 zeros. I'm going to ensure that I've typed in 6 zeros. Then let's go all the way until million and thousand. Let's see how long this particular function call takes. Observe that Python is taking quite a while to get through this particular function call. That's totally unnecessary, correct? I've already told you that million and 3 is a prime number. Why did this function call take such a long time? That's because we have such a large range and we are evaluating the s underscore prime function for every number within that range. That is totally unnecessary. Immediately after you've found the very first prime number, your search for this particular problem is completely done because you've already determined that there is a prime number within that range. So let's improvise has underscore prime function by using break statement. So if s underscore prime function returns true, then we have found a prime number. Then we want to subject the while loop execution to the break statement because we want to disrupt the normal control flow execution. Let me rerun the function definition cell, and let's rerun all the cells below it to make sure we are getting the same output. Observe that now when I ran the has underscore prime function call for the large range of million to million and thousand, the function call immediately gave the output as true. If you want to see which particular number gave you the prime value, you'll be able to easily use the print function call for it. I can call the print function in line 7 to print num. Let's rerun the function call here. Looks like we are getting million and 3 here. I'll wrap up this video here. In the next video, we'll learn about the continuous statement.